Welcome everyone. My name is Wes Rice. I will be hosting today's webinar, and thank you for joining us for Cloud Native Architecture Meets Cloud Cost, Design Strategies that Scale Without Surprises, presented by Harness and hosted by InfoCube. Before we begin, just a quick note, this session is being recorded and we will be available on demand for viewing. Within about 24 hours, you'll get an email with a link to this and the presentation itself. Questions are welcomed. Roger Sims, our speaker, I will introduce in just a minute, will be taking questions. Please use the chat or the question dialog. If you look in the interface, there's kind of like a hamburger menu on there. Ask questions there. I'll be monitoring it. And then I will ask those right after about 20-25 minute presentation from Roger. As organizations continue to embrace cloud-native architectures to accelerate delivery and scale with agility, many teams are learning the hard way that flexibility often comes with a cost. Right? Today's talk is all about addressing those challenges head-on. We'll explore how Infrastructure as Code IAC can serve not only as a tool for automation, but as a powerful lever for building cost efficiency into the very foundation of your architecture. Leading today's session is Roger Sims, Principal Engineer at Harness. Roger heads up the Infrastructure as Code Management product and also serves on the Technical Steering Committee for OpenTofu. He brings deep hands-on experience in helping teams design cloud-native systems that scale responsibly without those surprises at the end of the month. So again, as I mentioned, we will do about a 20-25 minute presentation, and then I'll follow with some questions, and I definitely want to get your questions. So any questions you have, pop them in those menus, and I will then bring those up to Roger. So with that, Roger, I will hand it over to you, sir.
Thanks very much, Wes. Let me just get myself sorted. And just to say hello, everybody. Nice to be here today. As introduced, my name is Roger. For the better part of the last 9 years, I've been building solutions to help customers manage their software, hardware, and cloud resources, including the cost element. The last 4 of those I've been working at Harness, and most recently working on our Infrastructure as Code management product, as said. Excuse me. The idea behind that project is, okay, you may have some infrastructure as code set up, but it's a certain level of scale that then needs to kind of expand and take on its own kind of life of management. To kind of, as a bit of a lighthearted, somewhat lighthearted introduction to today's session, I'm just back from vacation and was hit with a little surprise cost myself. Arrived at the car rental, only to find that the car we thought we'd hired was not quite fit for purpose. We were traveling with another family. I'd expected a large, people carrier, 8-seater, and it was not quite fit for purpose, which included a large, like the same price again in terms of rental cost upgrades. We've all had those moments, I'm sure, within our professional careers where we've been hit with something that was unexpected. Somebody left a res cluster running when they shouldn't have, with a test suite that wasn't actually running for maybe a few weeks on end. Discovered whole environments as various teams have been laid off and didn't know that those existed. The number of reasons are kind of infinite almost in nature. So today we're going to kind of try and explore a little bit about how we, one, can get on top of that cloud cost, and two, kind of get a little bit more predictable with how we get into that. So today's session will take fairly short, kind of run through the intro at the minute, some broader context about what we mean by these terms and what we mean by cloud spend and cost. The kind of 2 approaches that are commonly seen out there, and then a bunch of kind of examples to try and help us improve the predictability of what we're expecting to see, and then land at a kind of final typical journey, or what we kind of would be recommending to some of our customers as they're coming on to our ICM product. So without any further ado, cloud native architecture, it's great. The rise of cloud and DevOps has definitely come with the various different promises of the ability to be agile and for teams to shift, or companies to shift left, so that teams take on more of their own decision making based on their own needs rather than being dictated to, leading to faster innovation. And the rise of cloud native computing and DevOps has transformed how software is built, deployed, and scaled. I don't think anybody can argue with that over the last 20 odd years. So what we've seen is that the number of options out there of cloud services is expansive and ever increasing as well, I would say. It seems like every month there's something new coming out. We also see that it's incredibly easy to create and remove infrastructure. It's also incredibly easy for teams to use whatever technology they want to use. And there's a multitude of tools out there to make things easy. However, this agility obviously comes at a cost and a whole new set of problems to overcome. I'm sure many of us have seen the disjointed tools and the manual processes still existing. We can see high developer time spent on toil and repetitive tasks. Developers often force the context switch very quickly between writing application code, spinning into some YAML, running off to write some Terraform or Tofu, and the impact that has then within their actual development time. Developers obviously still spend some time waiting for the new specialists, that one person who knows how to use Helm. And of course, let's not forget about the infrastructure that gets forgotten. It's just running away, ticking away somewhere, nobody really sure why. All this obviously leading to ever increasing cloud costs. Sorry, excuse me. But what exactly do we mean by cloud cost? I think I've categorized at least three things here in terms of what the kind of cloud native architecture kind of brings to us. We've got resource costs themselves, developmental costs, and the ongoing kind of management and maintenance costs. Those resource costs are the actual costs that most people think about. It's the direct thing, the renting of services and resources from cloud and SaaS providers, your compute, your storage, your network, whatever it might be. But often there's a little bit of a hidden cost with some of those pricing models. Network transfer, for example, can often kind of bite. And of course, then there's the kind of resource utilization and trying to predict some of that. Many services come with a pay-as-you-use option, and while allocating for while this allows for linear increase with usage, it can also be difficult to predict. As said, this is what most people think of, and typically the most visible and easiest cost to quantify. And is often used for budget forecasting and cost optimization, and is often where you find a lot of those cost optimization tools sitting. However, that's not the only cost. We're engineers here. We understand that none of this stuff happened by magic. And it takes people and teams and staff and engineers to make this all happen. And the cost of creating and maintaining these resources. This reflects the impact of the architecture choices and the velocity or effort required to build and evolve the overall system. For example, developer productivity. Complex or poorly structured cloud architectures can slow down development, which then adds the same pain back in to those development teams. Technical debt is obviously a massive thing, and somebody somewhere has to kind of get on top of that. Additionally, our automation and our CI/CD pipelines don't happen by magic and always need a little bit of nurturing. I'm sure we've all worked at that one place where the only person who understood how the Jenkins build worked left, and there was chaos and pandemonium. And of course, there's the implementation of kind of detailed security controls and RBAC controls on who can actually do what. And then, of course, finally, there's the actual management costs. We want this infrastructure to be running. We need to know it's been running. And the cost of actually running this reliably, whether it be we incur costs by teams building out their own solutions or paying for third-party solutions such as Datadog or whatever that may be out there. These operational costs are associated with the provisioning, monitoring, securing, maintaining of cloud infrastructure. but they're often indirect, but crucial for the long-term maintainability and reliability of cloud environments, and so can often be unavoidable. But typically, the decision comes down to whether or not to build or to buy. So what can we kind of do about this? One of the things we've tried to do within the product I'm building out at Harness is to try and apply those DevOps practices onto the cloud cost management. By creating just another operational requirement, some say non-functional, then we're trying to build a tool that will allow you to kind of scale your costs with your business. Just as DevOps allows shifting left for testing and delivery, we can also apply the same strategy to cloud management. By considering costs, that operational requirement, we can build it both into our development and our operational practices. Note, the role of infrastructure as code is important here, not just on the development side, but also with integrating with the more monitoring side of things. So what does this actually look like? I've kind of boiled the old DevOps figure of 8 down to just those two kind of sides, the dev and the ops. On one side, we've got the AIC allows for visibility to be built in. We know what resources we have through the code that's been written. We can offer some safe defaults, experiment more easily, an estimation on cost of change, never mind things like policy and enforcement by using this. While on the ops side, things look a little bit more removed from infrastructure as code. The things like bill analysis, the tooling around right sizing, resource government tooling, and even things like anomaly detection and discovery of underutilized resources. However, infrastructure as code can help here by ensuring the correct information is in place to enable that. Just jumping on very quickly to the actual optimization examples. The first one I just alluded to, which is one of the simplest ways to get started is with what you already have. Most of us already have infrastructure that's running somewhere, or resources that are running somewhere. And what we kind of need to try and get to very quickly to integrate with the various billing systems that are out there is making sure that everything is allocated and categorized correctly. Each resource is tagged, and this usually allows us to hook into other systems and opens the possibility to set things like fitness functions. So we can start to send things like spend per environment, or maybe even set limits on things like sandbox environments or developer environments. Track resources per team to see what teams are regularly overspending, and identify unknown resources. It's definitely another kind of take on this side of things. And then also just to track spend on an application to predict the viability of this. Is it costing more to run this than it is to actually sell it? Do we need to increase prices? And various kind of takes on this. There are a number of ways to kind of implement this. On the screen, I've kind of very arbitrary bit of HCL code as a way to kind of ensure that particular tags are set. Some of the examples just given. These then get tagged into the actual running resource, allowing multiple third parties to kind of integrate from that kind of running infrastructure point of view. However, there are ways to kind of create homegrown options with API calls at the end of CI pipelines and various other kind of different techniques. Personal preference would be with the AIC because we can kind of manage this a lot easier, especially if we're kind of using some common modules to start to get this running. Very simple, but very powerful initial solution. Also mentioned CI/CD pipelines. And obviously, this is the bringing in more of the infrastructure of code side of things. If we can kind of treat our code, our infrastructure really like code, then we can use all the same processes that we do currently with code. We know how to review it, we know how to test it, set gates, set lints, etc. We can also set up these pipelines to run off PR triggers to enable kind of dummy runs to get planned information, make some analysis on it, and then return that information back to the PR, enabling the end user just to kind of sit there as if they were working with the regular code. The great thing about pipelines as well is that it's not a script that kind of needs to be understood by other people, and we can add in whatever gates and checks that we need. But there's additional benefits involved as well. You know, different things like if we see a particular pipeline running with a particular set of infrastructure quite regularly, we're maybe tracking that resources are going under change quite a lot. Maybe that's something that maybe then needs to be paid attention to. And as I said, we can add in whatever. From this simple case, we've got a simple kind of confirmed step that might kind of sit there and wait for user input. The next side, in terms of the pure kind of AIC side of things, just like any other code, we can modularize or create libraries for our end users, internal users to use. The idea here is that we can kind of either create our own modules, which have been specially tuned for cost optimized solutions, or we extend the existing provider modules that are out there, for example, and return those with the same defaults. This example is often used with the things like making sure S3 buckets aren't made public, but the same can be applied around limiting instance sizes and limiting kind of choice around what can actually be done. Ensuring things like an EC2 instance isn't sitting at an extra large by default if we actually only need kind of standard. We can kind of take this one kind of step further as well. This would be an option to kind of start to build in those tagging defaults and make sure that those are available. But we can also start to group modules together into kind of a common pattern that we might want to deploy across our organization. This was a little less on the cost optimization, but it could lead to a way of like, for example, if we need a web stack, being able to provide that with same defaults on everything linking together well. For example, best practices around possible modules that maybe force the use of spot instances, if that's something that it suits your business. Include some budgets and alarms by default, or automatically attaching tagging and monitoring, as mentioned. Many ways to do this. I speak mostly from the Tofu and Terraform background, but other options are available. The kind of simple way to get going with this is usually through some sort of mono repo, using the file system and being able to kind of pull in from there. But you can kind of go down the route of things like private module registry. Additional checks and guards can be put in place later to ensure that only those modules that have been kind of sanitized by some central team who've done the investigation are only ever used, and third-party libraries or modules are being exempt. Very typical to process to how maybe libraries are used within, say, your Java code or your Node code. Excuse me. Now on to more of the crux of how things might work. Cloud estimation could be plugged straight into those initial kind of plans and testing side of those pipelines. Can build this out yourself using directly the cloud vendor's API. Within the Tofu and Terraform space, though, Infracost is kind of the primary tool that's out there. What this can do for you is give you a report that, based on the plan that is made, that you can then figure out what the estimated cost would be for that. This is obviously just at the instance level. I'm working typically, unless you want to pay some money, we'll be working with the kind of the stock price of those cloud resources. Those give you the option to further break down into the individual resources, kind of adding to that cost. And what this kind of we see within our users is this is something that's quite invaluable to them. Many of them are at a scale level that they want to do that proper shift left and not be the bottleneck, but they also want to make sure that their internal end users are well aware of the costs that are being provided or being accrued. So this kind of gives them a very quick insight into, you know, is this increasing by a couple of dollars? That's fine. But if this is increasing, you know, by thousands and thousands of dollars, maybe this is something that that needs to be looked into or be made aware of. We'll talk a little next about policies, but this output could also then be plugged into the likes of OPA to then be able to kind of set further guardrails around your maximum spend or maybe some sort of percentage increase that is allowed. And as I said, on the policy as code, most of us have come across this already by this stage in our careers. The idea here is that we can define a policy with some sort of input, and then it will kind of give us back some sort of either warning or fail. As I said, OPA has kind of become the de facto choice here within the kind of cloud native world, but other options are available, especially within the cloud spend space. Many of the tools out there, including Harness's own CCM, Cloud Cost Management System, offer a bunch of policy enforcement at that kind of cloud level. The idea here is that we can now start to separate a little bit further. If we want to kind of take a different route around allowing teams to do things, maybe the module route isn't something that we can actually go down. This is another way to kind of start to enforce particular usage. So in this trivial example, defining that you must use either a T2 Nano or a T2 Micro instance and no others are allowed. And as you can see, it also includes a couple of the required tags. This can be integrated into your own pipeline. Harness itself integrates a lot of its kind of common resources directly into an OPA agent behind the scenes, allowing those kind of maybe SRE core teams or maybe security teams to be able to kind of apply these changes, enforce these changes without actually the end user really knowing what's there. So with all that said, what does a typical journey look like, or how do we typically want to work with a lot of our customers? I'll caveat this next bit with, I think pretty much no two infrastructure architectures are quite the same. Over the last year or two of this product and working closely with our customers, people come with all sorts of homegrown solutions, all sorts of requirements, most of which you can't really kind of predict. However, with that said, we do look at this as a bit of a journey, very similar to how you might treat any other kind of development journey. We start with visibility. If you don't know what you have and you don't know how to allocate it, then you aren't going to be able to go too far. So ensure testing and provisioning is handled via pipelines. Create those golden pipelines for people to make use of. Track those, make them easy to interact with so people actually enjoy using them. Ensure resources are tagged adequately and categorized adequately so that we can then start to build out those cost reports, make those available to the teams or integrate with the many kind of plethora of third-party solutions that are out there. We also push that you add cost estimation to your pipeline PR, making that cost change visible. We have this on by default within our own product, so it's just there as part of the overall Tofu plan step, as with the ability to kind of set these pipelines up as templates and things that are easily reusable by multiple teams. The next side is to start to build out your golden path via modules. That obviously can be a lot of work. It's quite labor intensive. The previous step can be quite easy within our product to kind of set up and get running with. However, this next step could be a bit more difficult and a bit more arduous. Some people will get to this, some won't. There are other ways of then doing that, as we said, for example, through the OPA option or other kind of policy agents. But also allows us to, we also kind of point out that you want to be trying to make out the maximum values, e.g. for your auto scaling resources. The next kind of side down is then that governance, and I guess I kind of overlapped a little bit there. Building out those kind of pipelines that people make use of, ensuring the previous steps that we just mentioned with policies. We also recommend that that you build in some sort of cost policies with that. One of the big ones would be even just a percentage up increase, because usually any sign of a massive potentially large increase is usually some sort of user error within the code. So try and catch that before it actually gets out. That can be triggering a warning to an end user or right down into an actual failure of your pipeline. There are more complicated cases here that I've also seen, but indicating like whether or not approval is required by some other budgeting holding authority as if things have kind of gotten too far. And then I guess the last bit is then some of the stuff that's already been going on is track these costs per application and business priorities, feedback your learning into the various constraints and government policies, and start maybe some experimentation with A/B testing. It's being made a little bit more easy with the infrastructure as code approach. And the final kind of holy grail, I guess, for many of these larger corporations is to build out some self-service portals, ultimately removing the user from the infrastructure as code itself and just interacting with modules that have been created for them. That might be a bit of the extreme side, but there are many options that we've seen here that work really well and flexibly. All that said, this is we feel that our infrastructure as code management module goes a long way to help you attain all of these things. It's a shameless plug right at the end. I just want to say thank you and look forward to your questions.
All right, thank you, Roger. So one question right off the bat. Shashik has a question. So there's a lot of architectural NFRs that we have when it comes to building our systems, security, reliability, performance. How do we balance some of those NFRs when it comes to trying to do cost optimization, leveraging infrastructure as code this way?
I'm going to apologize. I'm just back from holiday. Brain's blanking a little bit. NFR.
No, sorry, non-functional requirements. So performance, reliability, sorry.
No problem. Yeah, I often, I'm more of a developer than an actual infrastructure engineer.
Yeah.
Well, more of an architect these days. And those NFRs, I like to break them down a little bit further. I can't remember exactly where I got this from originally. I don't claim ownership of it. But they tend to be broken down a little bit further around the developmental and the operational requirements that are within this.
Yeah.
Those operational ones, I would definitely see cost as coming into. Potentially, the cost is a further non-functional, but it's one that I know that with myself, I try to raise with management and raise with product, for example, especially product, to be able to say, if this product is going to be viable, it needs to be cost effective. So we need to be able to define cost as an actual upfront NFR. Yes, those are at odds, and at some point, as with any of these non-functional or any functional requirements, they need to be balanced out, and priorities needs to be set, because we can't please everybody. We could build a super efficient, low latency, the best resilience that could be possible, but if it's not cost effective, we're not going to be making money off the back of this. Similarly, if it takes us 6 years to build out that side of things, the market will have moved on. So all of these NFRs I do tend to see is all in a little bit of tension with each other. Some overlap, others can expand out. But my usual take is to present this as here's another option that you need to be considering. The cloud kind of looks like it's for free because it just magically works, but there is a kind of hidden cost.
Yeah, sure. How do you balance like scalability? Like when I can see you run something and it's a single VM, you get a price for it. But when you've got that burst ability, or you could scale up quite a bit, maybe it's serverless, for example, like how do you get your mind around upper and lower limits when you're talking about what this might cost?
Yeah, again, there's no silver bullet to this one, definitely. For example, and I don't think this would be any way difficult to understand, we have a common architecture within Harness. However, it's built primarily as a CI/CD system, which has long living jobs, short amounts of compute. Latency is important, but not massively. We then moved into the feature flag arena, and obviously it's the complete opposite. The predictability isn't really there. We can't kind of scale back and kind of queue stuff up. If we start queuing up feature flags, like they're just going to drop on the floor. Our end users are not going to see the results they want. It's a very different kind of way of thinking. So we came across this. Lambdas, I think, and the similar functions are kind of good for that linear cost for burstability. They come usually at a bit of an expense. It's been a long time, but I remember a previous chief architect going in detail about how much more expensive they were than to run, for example, on Spotinst.
Yeah.
However, VMs obviously require some sort of redundancy if you want to kind of be able to scale up quickly. I guess the question is, how burstable can you be? How quickly can you let that traffic drop or move on? The thing that this kind of IC approach allows you is at least to put in some sort of limitations or some sort of set defaults. So if you're happy to drop requests at a particular level, then great. If you need some redundancy behind the scenes and allow things to scale, then that's what you're going to have to do. And cost is obviously going to be part of that. I'm maybe sounding a little bit like broken record with the previous conversation, but it depends. It depends on your business, depends on what your priorities are.
Yeah, totally understood. That makes complete sense. Could you talk a little bit about, I guess, the developer experience of using the tools to actually do cloud cost optimization? Like you showed things in the plan stage. So does this mean that I'm running it at the command line? I also saw that you saw it CI/CD. So do you actually deploy it with GitHub Actions and get like a runner that does it? Can you talk a little bit about the just developer experience of where you see these reports and what that looks like?
Absolutely. I can speak to my own experience of our own tool and a little bit more around those other tacos that are out there, and also just a possible build it yourself option as well. Harness primarily is a pipeline system. It's a DevOps platform, but we're built around this idea of a pipeline. All of the actions that we kind of take with this, our ICM module, all those kind of happen within the context of a pipeline. So that does offer the likes of a PR environment really nicely, really easily.
Yeah.
However, if you're just sitting there tweaking, you don't want to be raising PRs all day, every day, waiting for somebody somewhere to approve, to only just find out that actually that wasn't quite what was needed. So what we also have is the ability to run a CLI tool, which just interacts with those pipelines directly.
Right.
Works with the code sitting on your machine, interacts directly. Very similar to how the likes of Terraform Cloud, Terraform Enterprise work.
So
very similar approach that's available for other tacos. That could be something that's handled probably with other pipeline systems quite easily. Might require a little bit of work on your end to create some sort of CLI around that, just to trigger it. But it's not a massive inconvenience to kind of build that solution out. So I guess you got your traditional kind of PR, slightly slower turnaround time. You might want to be a little bit cleaner with your code, but then dropping back to kind of more that CLI. Engineers typically want to stay where they're working. So.
Okay, so I cut a PR, it'll go through there, run my lint, do any security checks, and I'll actually see like a runner pop up that shows me maybe a cloud cost report that shows what my infrastructure will cost it. And then you mentioned also something about like percentages. Like, so it'll show me what my current cost is, and then maybe like, is it a percentage that might change? What was that part?
Yeah. So the InfoCost tool breaks down into the two sections. One is the absolute cost change. It used to be this, it's now this. But then obviously it just breaks that down into a very simple percentage. We find at the minute that InfoCost tool by default works with list prices. Many companies have got sort of discounts and things, so not working off that. We find the absolute amount can be quite shocking to a developer who's maybe not used to how much cost is actually involved with running cloud services. But the percentage change can be more of an indicator of like a whoopsie, or more of like a oops, I just set that default to like, or 20 instances, I meant 2 or 200, and a cat can catch that. That report itself could then be fed into something like an OPA policy, and then you can kind of set restrictions on like, well, if this goes over a 500% increase, then that raises a warning. If it goes to 1,000, then yeah, let's just outright block it. So that's some of the power of linking all these various tools together, obviously, as we've seen in code for years.
So talk a little bit, so you just mentioned OPA, Open Policy Agent. Talk a little bit more about like what role that plays in, I guess, establishing guardrails when you're dealing with cloud costs.
Yeah, so the trivial example that I kind of threw up there was, it's a very easy way to, regardless of how somebody's writing their infrastructure as code, if there's a plan file or JSON file of any description kind of coming out from a dummy run or a no-op, indicating the changes that are coming in, then there's a way to kind of like indicate that whether or not those options are allowed. I had just slight tangent, but we'll come back to your question.
Yeah.
Previously was part of an architecture team doing a large scale standardization across the org. And very quickly you run into scenarios where those standards don't quite meet exactly what you're looking for. And there's always kind of exceptions. As I previously was saying, there's always it depends. And so you need to allow for that as well. So the OPA works typically on 2 options. It can warn, or it can completely outright deny. We recommend often that you use it mostly for warning, and then pushing that responsibility back to the end user with some sort of like approval gate for the actual deployment, to allow them to kind of make that decision around that. So that's often on the plan side of things. The cost side can be a little bit more black and white, but you can also start to build up quite complex pipelines or set of policies. I think one of the most extreme I've seen is, depending on what resource has been built out, will trigger a particular policy. If it's a warning, that then needs to actually go to another team to actually set some sort of approval over, or if it's not, if it's over a particular level, then obviously outright fail. So there are many ways that you can kind of build these tools, not just in the simple case, but kind of build layers to create quite complex process flows.
Yeah, absolutely. So in what you were describing before, you showed kind of a PR process for CI/CD. So I make a change, have a branch, I commit my branch, and then when I go to merge it, we run through and we do things like we typically do: linting, security checks, and then the cloud cost optimization. How does that change if we're using a trunk-based development approach where we're actually committing directly to trunk?
Yeah. Typically, I'm assuming by trunk, you're going to take snapshots rather than releasing every single change that's actually being pushed. Now, it depends on your use, but if you want to use trunk, what we typically see with IEC is you're then versioning that as well with kind of git tags and that. So at some point you kind of take a snapshot and you're like, actually, this is now good to go. We know this is safe because we've been doing the continual testing and approvals. But at the end of the day, we kind of then take this kind of version approach to things. That then needs to kind of be some sort of other pipeline that would then kind of take that, run through maybe some final checks just or quickly, and then kind of release, or maybe fuller set of tests to then kind of actually release that. The complication that comes in here is around how do you start to orchestrate that across multiple environments. Say you're running in 5 different regions. That then becomes a bit of a more of a Uber pipeline or a bunch of other kind of constraints that kind of come in to ensure that we release over to US East first, then West, then Europe, Asia, wherever it might be, whatever that policy might be, or if it goes and sits live for a while in that region, fine, then we automatically just paralyze that rollout to the rest of the regions. I'm not sure if that quite answers. I might have gone on a bit of a tangent on a recent kind of thought process, but.
No, I mean, I don't think there's a right or wrong answer. It's just how do you, if someone's using a trunk-based development approach, what recommendations do you have to institute it? So it seems right with snapshots. Okay, let's see. We got another question. What's the recommendation to run performance tests with CI/CD pipelines? So what are some of your thoughts around performance tests and cloud cost? How do you think about that?
Yeah, for depending on your setup, and what we've seen ourselves is those kind of performance tests tend to be run in isolation, with some sort of level of isolation. I guess there's 2 different ways of running it. One is test and prod, rely on your monitoring, roll back if there are issues, or roll forward if there are issues. The other option is around ephemeral environments. So spinning up an environment, running a particular load test, and spinning that environment down again.
Yeah.
Again, this is something that's kind of offered by a bunch of those tacos that out there working with Tofu and Terraform, and something we have as well. But those would be the kind of 2 big kind of cases. We would definitely kind of recommend that if you're wanting a full suite of tests for a major change or testing on that kind of side of thing, spinning up of an ephemeral environment, and making sure that it ends once the various kind of test suites run. That also applies for other strategies around like kind of tinkering and playing. Maybe you can spin that up, have some sort of TTL on that environment to make sure that it's not forgotten about and lost. Possibly also using the very basic kind of tagging strategy to ensure that tag is this is a development, or this is test. Highlighting within the actual audit that this cost, yes, it's a big spike, but here's why this was a big spike. It was we were doing something very deliberate, and we expected this to be expensive, but it was a required test to kind of run this through.
So in a kind of related question, and it's probably the same answer that you just gave, to be quite honest, but how do you not double your cost when you're thinking about like blue-green deployments or canaries? Like, how do you put controls, guardrails around it so you're not just like doubling things?
Yeah, again, it'll come down to kind of the architecture that you're using. The multi-region thing is relatively straightforward, and easy, because you can kind of do one at a time, and you use one almost like a test bed. The other option is obviously just to kind of run the tests ephemerally, and kind of kill them before rolling out.
Yeah.
I don't have a lot more to offer other than.
Yeah, I was gonna say it's still ephemeral, TTL, same type of things. Yeah, absolutely.
The other kind of side of stuff is there are a bunch of tooling. There's a bunch of tooling that's available out there. Harness is not on its own here, but you're detecting when services are not being used and kind of applying those auto stopping rules, and working from the other angle, not from the IEC angle, but more the how's this running infrastructure working, looking at the monitoring, being like, hey, there's been no traffic on this for the last few hours. Maybe it's safe to spin this down.
Yeah, that's interesting. How does Harness enable that? Like, what is that? Is that a Rego OPA policy that you create to do that, or is it something else that allows you to check for things not running and be able to shut them down?
So it's slightly different products. So the exact ins and outs I should be up to speed on, but I'm not. We have our own kind of proprietary governance engine that can then be defined as code, very specific to how that cloud cost management module work or product works. And you find very similar, there's probably half a dozen products out there that they're doing very similar things. I know a previous company had one, for example. So
yeah, makes sense. Makes sense. What? It's probably a similar question. Does that also track like drift that may happen in infrastructure, or maybe orphaned resources? Like how is that managed? Like all the time with cloud resources, I will often run in where I was building and I maybe don't have something that's automatically shutting things down, and I'll have drift or orphaned resources. Does that same product do that, or how do you deal with those?
yeah, I guess it could be a tie of the two. Drift specifically is obviously dealing with the infrastructure as code and the real world and what it thinks it's running.
Yeah.
So there's a bit of a tie between those two things, and you need to kind of figure out what's in play and what's not in play. And there's definitely a bunch of products coming to the market and some ideas floating around, talking with product management over the last few months around how we can kind of start to do that, because it is a very asked for feature. Being able to identify resources that are now orphaned from any IAC, and is that about bringing those back in? How long were they existing for? How were they created potentially? So there are definitely products in the market that will help with that. I'm trying to remember them off the top of my head. But the other side of things, and there's an interesting kind of trend with the likes of Gen AI, while not necessarily required, it makes it a lot easier to then take that list of orphaned resources and generate Terraform for those if you so desire.
Yeah.
Which is an interesting take. The drift specifically can usually be handled directly with IAC and the tooling that's available there. There are smarter ways to do it potentially, but the very kind of simple way is just to rely on the tools. So Tofu and Terraform have some inbuilt tools around that. It's just about periodically checking to see how that's running. There are obviously some costs involved with running those tasks or those pipelines that might kind of be checking for that, and some more interesting and inventive kind of ways to kind of like abstract that a little bit from the actual tool to allow you to kind of check regardless of what tool is being used.
If we're coming up, we've got about 10 minutes left. So if you have any other questions, please pop them in either the questions or the chat, and I'll be sure to ask them to Roger. So Roger, you just mentioned AI. I'm curious. So drift management, maybe looking at observability or reporting afterwards seem like good use cases for AI. What are you seeing, I guess? How is AI changing the space that we're talking about with cost optimization and with infrastructure as code to use that cost or to check the cost optimization?
Yeah, absolutely. I guess on the kind of third-party tooling that looks at your infrastructure and offers recommendations, we used to call it ML. We probably now call it AI. That tooling was kind of been there for quite some time. You're looking at the idea of right sizing, for example, looking at your usage, looking at what you've allocated, and kind of giving recommendations, and taking it one step further and actually implementing those recommendations for you. That's been part of this space for some time. On the bringing it around to IAC, I've been quite reluctant to get too far in, just given Gen AI is a probabilistic model. And the last thing I really want in my infrastructure deployments is some sort of probabilistic approach to it. The whole reason I'm using IAC is because I want this to be declarative. Yeah. That said, there are a bunch of periphery cases where this is then being used. Not so much in the cloud space, but I saw an interesting one recently where they were using Terraform deploy, but then using like an AI agent to kind of go off into your own network, discover what else is being touched by that change, not just the bits within the root module that you're changing, but what else might be there. So if you're changing a gateway, for example, then what's actually relying on that might not be in the change set that you're doing. That is less of a cost piece, but is definitely some of the interesting stuff that we're seeing. The other one I've mentioned already is that idea of looking at resources that you want to create and being able to generate that for you, the kind of code generation that we've seen for some time now, used to. And beyond that, I think it's possibly about bringing those recommendations a little bit forward. So if we can plug, it's very similar to how we run our running infrastructure against some recommendations with known usage, can we apply that same thing to, for example, a plan, and be able to kind of come out with a recommendation that maybe that change isn't required. Oh, by the way, as well as making that change, maybe you want to look at upping this value or lowering that value, depending on what is being determined between the actual usage and the proposed changes. There's definitely a lot of like edge cases where looking at kind of recommendations and further automation.
Now, are these like running reports and then feeding it into like an LLM to be able to give you these recommendations? Are these CLI integrated? What are you seeing?
These things tend to still be within large systems. So storing masses of data, looking at your Grafana instances, running against the actual cloud provider stats, and then doing a bunch of compute. Some may be LLMs, some be a bit more typically more kind of ML models.
Okay. All right, I want to go back to you mentioned before, like Golden Path modules, being able to lay down modules that then I can use as maybe a platform team sets up a series of modules, and then I use it, and then I have same defaults, same scalability characteristics, things like that, by just using that Lambda module or whatever it may be. What a couple things that I have a couple questions in that space. It's really easy when you're in a platform role to be able to go maybe overboard and restrict too much of what's there. Like, what do you recommend on things that should go into that Golden Path module and things that maybe you shouldn't put there, that you should leave up to the team? Like, what do you recommend and where do you draw that threshold?
Yeah, drawing on experience. This was something that I saw in a previous setup where there's large standardization, but there was a team who were heavily using Spot instances, and they were seeing great value out of that, and was working fantastically for them. A company that was acquired in, and they were kind of then pushed to make use of some centralized systems that we had with more long-running jobs, and things just started to fall apart because they were plugging in with their existing side of things, but obviously that Spot-in setup that they had and was working well didn't work particularly well with the idea of like a long-lived stream listener, for example. And so yes, I've seen firsthand that too much restriction can really kill something that was working very well. And so I guess it's back to one of those kind of like, it depends. You need to understand what your actual workloads are, and understand where you're kind of going to dabble with your restrictions. Is it as simple as like you must run Postgres rather than MySQL because we know how to operate that and we know how to make that cost effective? Or is it right down to you must run these specific instances with this size of memory and no more, taking no effect on how that team is actually building out their application? I fear for that because that kind of brings us right back to the almost bad old days where you're just dictated to that here's what you have. So in those cases, you'll understand where things are non-negotiable typically. And where there's a little bit of gray area, I'd push maybe for not so much restriction at the module level, and maybe bring it more up to that OPA level, where you can kind of guardrail it at a slightly less restriction if you need. You present a warning. If you see enough of those warnings, then you start to see where the breaking points are. Maybe something needs to change within the feedback loop given back to that kind of platform team. But yes, standardization obviously great for cost effectiveness, but not necessarily useful for actual real world use. So.
Yeah, awesome. Well, Roger, we're at about 5 minutes before the top of the hour. We're going to stop at the top of the hour. Any final thoughts, suggestions, or things for the audience to take away?
I presented quite a few very simple things there, along with kind of maybe not pointers to actual tooling, but there are plenty of tools out there. Hopefully it sparked a little bit of thought around a few things that you could kind of implement yourself. And it's probably never too late to get started down this road of actually trying to save some money. Most teams, it comes to them whenever they get a knock on the door from finance asking why the bill is so large. So a little bit kind of goes a long way, and probably the best way to kind of get started is today.
Yeah, Roger, I find these as a really good indication of the maturity of teams. Like getting to the cloud, for example, is one thing, but getting to the cloud responsibly is certainly another. So these are some great tips, great techniques, some things that maybe I haven't specifically thought about, but maybe I just have been doing. So thank you for walking us through all that. If you'd like to learn more or reach out directly with Roger, you can find him out on LinkedIn. There will be an email coming out within the next 24 hours or so that has a slide deck, has additional resources that you may want to reach out to. But with that, Roger, thank you for the tips, and thank you all for joining us.
It's great, my pleasure. Thank you.